Hello everyone, I hope you all are doing great. This is the seventh lesson in the chapter 3. Differentiation is the chapter. We will be deriving exponential and logarithmic functions. I hope you remember the previous few lessons. The chapter 3 was about power rule, chapter 4 was about product and quotient rule, the chapter 5 was chain rule, and the chapter 6 was trigonometric derivatives. Now, these are very crucial to come to this lesson. The previous four lessons are required. So if you have not watched it, if you just jumped over here, please take some time, go back, be thorough with the previous lessons, and then move ahead. Now, in this chapter, we will explore how to derive exponential and log functions. We will start the lesson by looking at the learning objectives. They are to find the derivatives of exponential functions, to find derivatives of natural logarithmic functions, and to solve real life problems using derivatives and exponential and log functions. Now, exponential and log, they are inverse of each other and they have certain rules. There's a formula to use when it's exponential or log functions. We will look into that now. There are some theorems which we come across, that is the formulas of derivatives. We will have to use this. The first one, when a is a constant, any number greater than 0 raised to the power x, this is an exponential function, and the derivative would be a power x. You have to keep this as it is first, and then multiply that with ln, provided ln of the constant number. So I'll just give you an example over here. Wait, let's see all the three and then I'll give example for all three. And this is the special case of exponential power where it is Euler's number, e to the power x. When it's e to the power x, you just write it as it is. This is the only derivative which remains same. This does not change. So it's the same one. And the last one is natural logarithmic function, log functions. Now when you derive log, it is just whatever the ln is there, right, that dissolves and it becomes 1 by x. So these are the three theorems which you must remember. You do not need to derive each of them, but you should know these theorems or the formulas. I'll give you an example for each of these. Let's see now. Imagine I have 3 to the power x. The dy by dx means the derivation of this would be equal to, write that as it is, 3 to the power x, natural logarithm ln a, what is this? That's 3, so multiply it with that. Okay, natural logarithm of, you can call it ln or lan, I just call it lan, so for short, that is the thing. Now what about this one? E to the power x d by dx. Whenever you have anything, e to the power x, e to the power 2x or anything, whatever is that itself will be the derivative. But if at all this was another function over here, chain rule, then you have to solve that. But for now, it's e to the power x, it just remains that. Okay, it's better I change this. Say, imagine I give you e to the power 2x. Now, this e to the power 2x would be e to the power 2x itself. But remember, this is chain rule. What is the derivative of 2x? It is 2, so you need to multiply this at the end because it is a chain rule over here. This was a straightforward function, nothing else. But here, since there is a chain rule, you multiply this. Now, let's do this. Ln x squared, imagine. The derivative of that is it will be 1 by whatever is this. Here it's x squared. Then since this is a separate function, you need to derive this. It will be 2x. This is the chain rule. Now before I begin, I just want to recall about chain rule. What happened is when I did this in the class, my students were a bit dodgy in the chain rule. So I give an example. So let me do that example here and I will continue. Let me just use that. Yep. Here we are. Now, I will take an example, say, I can't recall what example I've taken, but I'll just take a new example, say 3 sine 2x cube plus 1, the whole, this one, sine is taken to the power 4. Looks complicated. Let's do it one by one. This is the given question. Now, first thing, what you need to do is understand which is the outer function. It is like peeling up an onion. You know, onion. So something like this, onion. So you peel the outside layers one by one, right? So imagine, understand what is the outer layer. The outermost layer, when it is a trigonometry or anything like a chain rule, will be the power. This is the outermost layer. So you need to understand, this is, by the way, this is the constant. I'll use black over here. This is the constant, right? This remains. 3 doesn't make any difference. It just remains outside. That's it. That's a number, constant. Now, whatever is inside, we are just dealing with it. Is that okay? So here, what I will do is, first, let me take the blue color. Here it is. Now, use the power rule. The 4 will be down here, 4. And when you derive, imagine this entire thing over here inside the bracket is as x. If it was x to the power 4, it is just 4x cubed because you reduce this by 1. Same way, 4, whatever is there, just think of it as x, whatever is there. Sine 2x cubed plus 1. Now I'll just use the bigger brackets here. The whole power 3. This is just the power 4, the power rule. I've just used the power rule here. That is it, what is done, okay? That is the only thing that's done here with the power rule. Now, what is the next part? Next part, let me just write this 4. This is done. Next part of the onion over here. First, power rule. This is the most important, the outermost function. Now go inside. The inside one would be sine, right? This is already gone. This is just outside thing. Imagine that as the bud of this onion. You just remove and take it away. So that's removed away. Now you start peeling it off. You peel the 4, that's outermost. Now then comes this inner one, sine. Is that okay? This is done. No more thinking of it. I will just put an X mark. You did the power rule. It's done. No more. Here now you have sine. Let's derive sine. What happens when you derive sine? It will become cos. And now whatever is this, just imagine it has to be x. What is the derivative of sine x? That is cos x, isn't it? So cos, here instead of x we have 2x cubed plus 1. This is the thing. Next, what else remains? Now this is done. So the outermost layer is done. This is done, sine. What is remaining here? The last layer is remaining. Let me use this color. Here, this part is the last thing that's remaining. There's nothing else. Outermost, next, and then the innermost. Now derive that. That will be, when you derive 2x cubed plus 1, it's going to be 2 comes down, it'll be 3 comes down, it'll be 6x squared. This will be 0. So what's remaining? It is 6x squared. Derivation of this is 6x squared. Now this would be the answer. I'll close the bracket now because all this will be, this is the answer. All things are multiplied. One more important thing to remember. When you're deriving chain rule, it's all multiplied, multiplied, multiplied. Is that okay? Now if you want to simplify this further, you can easily simplify by multiplying all the numbers together. 6 times 4. 6 times 4 is 24. 24 times 3 would be 48, 72. So just multiply all the numbers up. I'll just write it. Numbers is 72. Then now it's up to you to rearrange. I'll just write the constant first, 72x squared. Then I will write cos, because it doesn't have any power, cos of 2x cubed plus 1. And then multiply it with sine 2x cubed plus 1, the whole power 3. Or what I can do is, here I can just write sine cube, because if I write cube here, this is the same thing. If the whole cube, and if I put a cube, it's the same thing. So this is just the short form. So this is the final answer. You can see this. So this entire thing is the derivative of this. If you d by dx, that is derivative of this entire thing, would be this answer. By using chain rule, you're using it nearly 3 times. I hope this is clear. This is done previously in the previous lessons, but I just want to bring it out because you need to be thorough with this. How you do it, all the outer layers and everything, and then you come inside. The constants are always just outside. They does not do anything. You can't derive this. Don't make this 0. No, you just keep it aside and only derive whatever is inside with the outermost, then innermost, and then innermost. So this is how you basically use a chain rule 3 times. Okay, please remember this. Now we will go to this concept. Why I told you this, it's important to know what is outermost, right? It's power 4. But when it comes with exponential, it's a little different, which I'll tell you in a while. Now, if you're thorough with these formulas, these are exponential and the last one is logarithmic. Let us solve a problem. We have got a real world problem to start with. That is, if the value of 10 dirham investment doubles every year, its value after t years is given by v of t equals 100 2t, 2 to the power t, sorry. Find the instantaneous percentage rate of change of the value. Now this is, the thing is, they have given you the value after t years is over here. After investing this t years, it's over here. We need to find instantaneous percent rate of change. That means the slope. What does that mean? You need to derive this. Whenever you hear this rate of change, instantaneous, percentage is something different. I'll tell you in a while. But instantaneous rate of change or something, that means you need to derive the given value. The value is v of t equals 100 2t. Just derive it. Which is the derivative formula. This is a constant, right? 2 is a constant. It is not e or anything. It's just a constant. So you need to use this particular formula. Let us solve it. I'll just write it over here. V dash of t equals 100 is a constant value. Leave it aside. This 2t can be derived. What happens? It will be 2t multiplied with natural logarithm 2 only. The constant. Don't write t again. It's only ln 2. This is the answer. Now, that is the derivative. You can see that's very straightforward. That's the derivative. 100 multiplied. This all multiplied with 2t natural logarithm 2. Now we need to find the relative rate of change. Okay, now because they have told percentage rate of change, that's the relative rate of change. This is just v dash divided by the original value. Let me tell you how this is. Let me give you a simple example of say change in weight. Now imagine some person A was 75 kgs. Okay, he went to gym, he built himself up, he bulked up, and he became 90 kgs. Okay, so this is healthy weight for his height and everything under the BMI. So he gained a lot of muscle and it's a good weight. So from 75 he went up to 90. What is the increase in weight? The increase is 15, right? So now if you want to find the percentage or relative rate of change, you need to write the increase, the weight increase, that is 15 kgs, divided by the original amount, not the final, not the derived or anything, it's the original amount, right? So it's 75, so it'll be it's 1 by 5, that is how much? 0.2 or 20%. Is that clear? So there was 20% increase in his weight. He increased his weight by 20%. If you multiply 20% to 75, it'll be 15. So his rate of change of the rate of change, relative rate of change of weight was 20%. The same thing here, we have the original value given and we found the instantaneous rate value. Instantaneous is at that particular instant, that is derived. Now all you need to do is the change, rate of change divided by the original value. This divided by the original value. What happens? 100. This cancels out over here because you're dividing it, this and this. The answer is natural logarithm of 2, ln 2, that is corresponding to 0.693. How do we get that? You can easily find it in the calculator. You can take your calculator out, and over here you can see ln, natural logarithm, to close the bracket, the value is 0.693. That means you need percentage multiplied by 100, you're going to get the percent 69.3%. This is the thing. The percentage rate of change then is 69.3 per year. If it's compounded continuously, provided it's compounded continuously. So that's the answer to this particular question. Derivation is very important. Here you're using the constant, okay, exponential derivatives. Now we will go to the next problem, that is the derivative of f of x equals 3e to the power x squared. Now here we are just deriving many problems, okay, continuously, just using the derivative. Let me show you all the three formulas. Three formulas are this, this, and this, okay, where exponential is a constant value, exponent is e, and natural log. Look at this given question and choose the correct formula. Which one do you think? Here there is a constant value, but that is multiplied, so it just remains as it is. What is the function? E to the power x squared. It's not this, it's not this, it's this one. Let's solve. So here it's a chain rule. This stays out. You need to derive e to the power x squared. Now don't think, oh, power, it's like an onion, right? The outermost. Yes, it's like the onion, the outermost thing. But not when there is e to the power anything. Not for exponentials. Not for log. For log and exponential, that's why these are in a separate chapter. It is different. You need to know here, whatever is there, that is later. You need to solve exponential first. So the derivative of exponential to the power anything is that itself. Now I have to write e to the power x squared. Now multiply the chain rule. That is done. So let me do this. E is done. Now what is remaining? X squared. So how do I do x squared? It will be 2x. That's it. So this is the thing. Now we can just multiply 3 times 2 is 6, x e to the power x squared. That would be the final answer. I'll repeat again. This is a constant. Leave it outside. Here, since it's exponential, Euler's number e, the special case of exponentials, what you need to do is e will remain over there. Sorry, e will be derived first over there in such cases. Not the power, not the x, e. Now, the derivative of e power x is the same thing. So, write this given question as it is, and this is done, derived. E is done, derived. What is remaining? The chain rule, x squared. So, derivation of x squared, 2x power 1. 2 minus 1 is 1. That's it. Now, we can just multiply the numbers. 3 times 2 is 6. X e to the power x squared. Is that clear? It's very simple. Now, please do try this by yourselves, and then we will continue. I hope you at least tried, at least paused and looked through it. Now we will solve it up together. Before that, let me see all the formulas. Oh, okay. It's anyways, I think so. I forgot the admission. It was there anyways. So the formulas are the three formulas. Here it's again the same one like the previous problem. It is just e to the power x. But is it only that? If you look closely, you will understand there's this function x as well. There are two functions. So what do? X e to the power 2 by x. These are multiplied together. This is a product rule problem. It's a product rule problem. So what you need to do is, remember the product rule. U, v, if those are u and v function, it is u dash v plus u v dash. If you, I remember one of the students asking me, can we write it u v dash plus u dash v? Yes, you can write it like this. But I always ask students to follow this method. Why? Because if you remember this, then your quotient rule, I'll just write over here the quotient rule, T-I-E-N-T, quotient rule, the division rule, that is, what is that? U dash v minus u v dash. Only the thing is it'll become minus here and divided by v squared. Here you're not supposed to change. If you change this as uv dash minus u dash v, it's absolutely wrong. So make sure you stick to this form itself. U dash V, first you derive the first term, multiply it with the second term as it is, plus first term as it is, derivation of second term. Okay, now we will solve this. The first term is derived first, that is x derivation is 1. 1 multiplied by what is V as it is, e to the power 2 by x. Now, plus u remains as it is x. Now derive the second term, derivation of e to the power 2 by x is as it is first, and then whatever is up. What is this? Here you need to derive 2 by x. What is the value of derivation of 1 by x? It's negative 1 by x squared. If you remember how this happens, take this x to the above, it will be x minus 1. So this derivation will be minus 1 x to the power minus 2 because you're subtracting this, or you can write minus 1 by x squared when you take it down. Here I'm just going to apply the rule minus 1 by x squared, but don't forget it's not 1, it's 2, write the constant 2. If it is, say, over here 4, it'll just be the same thing, 4 by minus 4 by x squared. So I directly wrote this, these are all multiplied. Now I'll try to simplify a little bit further. Here it'll be e to the power 2 by x plus, here what happens? There is minus 2 e to the power 2 by x. Now here you can see x and x squared cancels, okay? And what is remaining is only x. Now you can take this minus out. You can simplify e to the power 2 by x minus 2 by x e to the power 2 by x. You can remove this, it's same terms, right? You can remove this common out. Let's take this common out, like the distributive property. Here e to the power 2x is common outside. What is remaining? This is gone. Or basically divide both the sides, multiply here by e to the power 2x and divide both the sides over here by that. It'll be 1 minus 2 by x. This will be the final answer. Look at the distributive property. If you multiply e to the power 2 by x over here and over here, you're going to get the above answer itself, right? So this is just manipulation of the equation. So this will be the final answer. Let's just double check. E to the power 2 by x, 1 minus 2 by x. Yes, that's the correct answer. I hope this is clear. Here we are using the product rule. uv, u dash v plus uv dash. And derive the first term, it will be 1, second term remains, plus first term remains, and the derivation of this is e to the power 2 by x, and this becomes negative 2 by x squared. And then this remains over here, this will be minus 2 e to the power 2 by x, and we can even further simplify. This is, see, this is the answer basically, this is fine. If it's writing, even if you write so much, it's enough. Unless and until they ask you to simplify to the fullest or something, or this is more than enough, this simplification or this. If it's MCQ, that's the problem. Anything can be the answer, so try to simplify further. So that's how we solve this problem. We'll go to the next one. Okay, these are the formulas. We chose this one. Here again, we have another easy problem. Please do pause the video and try to do it by yourselves. And it's exponential again. Let's see which is the formula. This one or this one or this one. Take your time. I hope most of you are told this is the correct formula, and yes, that is the formula. Let us solve this now. Here, not these two. This is the one because it's a constant. Here what you do, let's write 3. See, a to the power x derivative, same term first, write that as it is. 2x squared, natural logarithm. What is the constant? It is 3. Now, don't forget the chain rule. Derivation of this. 2 comes down. What is derivation of 2x squared? It is 4x. 2 comes down, we'll multiply with 2, it will be 4 and x. So, 4x is multiplied. This is the answer. That's it. Isn't it easy? Okay, now I'll just tell you what has happened over here. 1 second. Now don't forget, see, all the values over here. See, 3, 2 power x squared is there, ln 3 is there, 4 is there, x is there. It's just that they have just rearranged. This is it. But here now, they have written the constant. Generally, the constant numbers are written first. And then, see over here, this is also a constant. So then that is written. 3 2 power x square is written, and then you write x and then exponential or log functions, that is ln 3. This is a single term, okay? That's why they have written it like that. Just remember always, okay, it's my bad. I'll tell you what is the exact rule. Sorry. It's always the constants. I told you the constants are first. So 4 is a constant here, yes. Ln 3 is a constant. If you put in the calculator, you will get a value for that. So ln 3 is also a constant. These are the constants. Then x, and then all exponential, log, and everything. Look at this. This is an exponential, right? Because x is there. So 3 2 power x square. Okay, this is the thing. Always remember it's constant. Though this is log, yes, it will be over here. But since it's log 3, if it was log x, it would be somewhere over here or over here. Okay, but since it's log 3, this will be a constant value. There's a value for it. If you put in the calculator log 3, you will get the answer. But since here we know the x value, therefore this comes as a constant. 4 ln 3 x and then the exponential function. I hope this is clear. And now we move on to the next one. Another real world problem about finding the hanging velocity of the hanging mass. This is the question. Let's go through it. If you build damping, that is resistance or motion due to friction, for instance. Now this is like, imagine a spring. Okay, sorry. Imagine a spring. You know the spring, right? Like this. Oh, okay. A better example is, let's say, rather than this, I'll tell you a ball. Say a tennis ball. You drop it, bounce it. It'll go up, down, up, down, up. Okay, it reduces. Ultimately, it'll stop, isn't it? This is the thing. Whenever there's friction, it obviously damps down and it comes to a halt position. Okay, that is about it. In a spring model mass system, the vertical displacement at the time t, mass hanging from a spring, can be described by, this is given over here, this value, and a, b, x are constants for each. Yeah, these are the two equations. The displacement u1 of t, e power minus t cos t, and second one is e power minus t by 6 cos 4t. Sketch a graph of motion of the weight and find the velocity. This is very important, finding velocity. Now, usually this is done by graphing calculator, because if you have to otherwise do the graph, it just takes eternity, you know. It takes a long time. It drives you crazy. It drives me crazy to graph this. You know, I would never do that. Unless I'm forced to, because you can do it the easy way is take x values, y values, put them, and then you will get the answer. Change the mode calculator to radian, put some values, proper values, and then you'll get some answers like graph. But let's look into the graph directly over here. You can see the first one. If you graph this first equation, there's a jump like this, and it comes little movement, and it stops. Look at the second one. Jumps up, down, eventually it'll come to an halt. So this is about the graphs. But that's the displacement that's given to us. How do we find the velocity? You must remember, to find the velocity, when you have displacement, see over here, you have position or displacement u, you just have to derive this du by dx. That would be velocity. Okay, so u dash, that is u dash, would be velocity v. I hope this is clear. So just derive these two functions. Let's derive it quickly. How do you derive it? Remember which formula? Only the exponential formula in both the cases. Let's derive them quickly, because we have to use the product rule. I'll just write the product rule and then I'll explain it. The product rule is given by u dash v plus uv dash. You can see the derivation of e to the power minus t, because that's the first term, u, and this is v. Second term will remain same, v will remain same. Now e to the power minus t remains, and the second term will be derived. Same thing will go to the next function as well. I'll just write over here u v, it's u dash v plus uv dash. Now we will start deriving. What is the derivation of e to the power minus t? It is e power minus t itself, but this is a chain rule. Why? It's like e power x power minus x. Let me just write it over here. How do you derive e power minus x? You write e power minus x as it is, and then you multiply with minus 1. Why? Because the derivative of negative x is minus 1. Derivative of x, so e power x, and it's 1. So we don't write this, we just write e power x, right? E power x only. But if you have, oh, sorry, that was a bad thing to do. I'll just go back quickly. Oh, okay. Now, if you have, say, only minus x derivative, it is minus 1. If it's x, it'll be positive 1. So sign really matters here. And that's why what we do is we have to derive this minus t, that's the chain rule. And next step, it'll be minus. What happens to cos t? It remains. This derivative is same. What is this? It's a single function, cos t only. So you just derive cos t. It'll be, oh, cos is minus sine t. Oh yeah, they have changed the sign here directly. Remember, the derivation of cos t is minus sine t. Let me just do this over here rather than just telling. See, this u dash is e to the power minus t and multiply with minus 1. Okay, and then it's cos t plus e power minus t. Derivation of cos t is minus sine t. Now multiply the signs, it will be minus e to the power minus t cos t plus, sorry, it's not plus, it's minus because this minus is multiplied out, e to the power minus t sine t. You can remove this out, common. I don't think so that's required. You can, let's just see the answer. Okay, that's removed. Anyways, simplified further. What's done here? All you're doing is, see, this minus e minus t is removed out. So what is remaining is cos t plus sine t. Now, if you multiply this inside, you're going to get the above equation. So it's balanced. It's just that you're removing a common term out. Okay. So I'll just write over here, say it's x squared y plus x cubed. You can see x squared, and this can be written as x square and x, right? You can split this up. So x square and x square is common, so you remove them out. It'll be x squared into y plus x. Now, if in case I use distributive property to multiply back in, I'll get x squared y plus x squared x, that will be x cubed. I'm getting this equation or this equation. It's the same thing. So I hope this is clear. So this is how you derive it, and that's the answer, the derivation. And the same thing is done over here in the next, something popped up anyways. So this is the derivation of the same thing, e to the power minus t by 6 cos 4t. How? Derive the first term, second term as it is, plus the first term as it is, derivation of the second term. When you derive this, you're going to get negative 1 by 6. Let's look over here. When we derive this, you're going to get, okay, I'll derive this as well because it's better. Here, when you derive this, first will be e to the power minus t by 6. Then multiply. What is minus t by 6 derivative? It would be minus 1 by 6. Derivation of t is 1. And the constant, everything remains. So here it will be minus 1 by 6. Then cos 4t plus e to the power minus t by 6 remains. What's the derivation of cos 4t? It will be minus sine 4t into 4. Why? Because cos is done. It is sine 4t. And then now whatever is inside, like onion, the outside is done. The inner function is 4t. Derivation of 4t is 4. That's how we get it. And what's remaining? Just multiply this and just rearrange it. That's the main thing, okay? Whatever we did, just then rearrangement. You can see over here, minus 1 by 6 is written first, and then e to the power t by 6. And then over here also cos 4t, and then minus, the numbers are written first, and then the arrangement. That's the same thing. If it's writing, if you write so much, it's more than enough, you'll get the full marks. So that's how we basically solve this. I hope this is clear. Now then we will move to the next problem. Here we will solve logarithmic functions. Now the formula is ln. Now I hope you can see it over here. Derivative of d by dx of ln x is 1 by x. That is natural log 1 by x. Now here we have to derive ln x cube, ln x square plus 1. Various types of problem. We will do it simultaneously, so we will understand the difference between them. First problem, you can pause the video now and do it by yourself because you have done it before. Now, before I go further, you must understand what is what. How do we derive each one of them? First thing here, it's product rule. Why is it a product rule? It's u, v. So the product rule is u dash v plus uv dash. That gives me x dash, derivation of x. What is derivation of x? It is 1. So I'll have to get 1 multiplied by ln x. Plus, what is u? U is x. What is the derivation of ln x? It will be 1 by x. You can see over here it's 1 by x. And this cancels off. X and x cancels off. You're remaining with ln x multiplied by 1. It's the same. Plus 1. This is the answer. Derivation. F dash of x. Derivative. What is g dash of x? This is very simple. Oh, sorry. It is simple, but there's an important thing. Now, before we start deriving, I'll remove this. We need to use a certain thing called the properties of log. Do you recall properties of log from grade 11? When I asked my students, they told they don't remember the last week or the last day. So how can they remember from grade 11? No worries. The property says this. If you have ln x to the power a, whatever is this power, it comes down. Even it can be a constant or a variable, it just comes down. A ln x. How does it help? The thing is, you can try this solving in calculator, or you can just go to the, I have done the video already on this, but it's just for one problem, so don't go to the entire video. But you can check the properties by using calculator. You can get the same values and prove it. But here, just whatever is there comes down. This is not derivative, it's not power rule or anything. It's the rule of natural logarithm or log functions, logarithmic functions as a rule. Whatever is the power for this x, anything. If you have ln, say x square plus 1, not here, it should be x square plus 1. To this ln, the entire one is cubed, or to the power 4. This number comes down directly. It is 4 ln x square plus 1. Okay, I hope this is clear. Now we will solve the given question. Here, what happens? 3 comes down. It will be 3 ln x. We have not done derivative. It is the same function with the property of log. Now we will derive g dash of x. 3 is a constant. Leave it. What is the derivative of ln x? It is 1 by x. So the answer is 3 by x. So simple. What about this one? Here, h dash of x, there is no property of ln to be used. There is no power here. So just derive this 1 by x square plus 1. What is it? Derivation of ln x is 1 by x. But here we don't have x, we have x square plus 1. So we write this. Multiply, chain rule. This is done. Derive this, whatever is remaining. X square plus 1 is just 2x. This becomes 0. 2 comes down. You can write this as 2x by x square plus 1. This is the answers for the derivatives. I hope this is clear. Here we have to use the product rule. Here it is a combined chain rule. No, sorry, just constant and that's it. Here it's a chain rule. These are the 3 cases and the answers are over here. It's very simple. 3 by x and last it's 2x by x square plus 1. I hope this is clear and you're thorough with this. Now we move on to the next problem, that is analyzing the concentration of a chemical. Okay, let's see what this is about. The concentration C of a chemical after t seconds of an autocatalytic reaction is given by this. Concentration C of t is equal to 10 by 9 e to the power minus 20 t plus 1. Show that C dash of t, the derivative of this concentration, is greater than 0 and use this information to determine that the concentration of the chemical never exceeds 10. Okay, there's a lot of things. Let's do it one by one. First, we need to derive this. They have told show that this is greater than 0, right? Let's derive it. Now don't think of, oh, this is a quotient rule, division. No, don't stop for a minute. Don't directly use the rule. Look into the problems. You can avoid quotient rule at times because here this is a constant, right? 10 is a constant. Don't go to use the quotient rule. Leave the 10 aside. Bring this term up. It'll be 9 e to the power minus 20t plus 1 the whole power minus 1. Now we can use the power rule and solve it, isn't it? So that's what we are doing. Is that clear? Now let's use power rule. What happens when we use the power rule? Let me solve it over here. It's very straightforward as well. Just you have to derive it again and again. Let me just do it over here. So now the minus 1, okay, let me just go up. This is minus 1. So let us derive the power rule. The power, whatever is the power, comes down. So it'll be minus. So 10 is a constant. I'll write minus 10 because that minus 1 times 10 is minus 10. And you're remaining with this. Minus 20t plus 1. Now this is done. This is done. Okay. I'll just use the LO to put a cross over here. That's done. Now let me use the blue color and do whatever is inside. Let me derive what is this, whatever is inside. Is that okay? The derivative of whatever is inside will be left side. This side is 0, so plus 1. Don't ignore that. Only this one. 9 e to the power minus 20t as it is. Here exponential is done. But now whatever is up must be derived. So this exponential is over. What is up? It's a chain rule, right? There are so many chains. Now I will derive that. It will be minus 20. That's it. Okay, why minus 20? Minus 20t would derivation will be just minus 20. This is 1 because it's 1 over here. T will become 1. This is the derivative. Now let's write it up together. Let me use another color. So I'll just use this one. It'll be minus 20 times 9, 180, and multiplied with 10. It'll be minus will be plus. First of all, negative is gone. It will be plus 18, and there are 2 zeros, so 1800. And what next? This is the values. So it'll be e to the power minus 20t into e to the power. Oh, I forgot this minus 1. I'm so sorry, guys. There is a minus 1 over here. That's important. If I don't, sorry, it's minus 2. Okay, I'm very sorry. I apologize for that. I hope many of you caught that. Look here. I forgot. I took the power down, negative 10. Then I wrote this. What happens to this? It'll be minus 1 again. So it'll be minus 2. My bad. Now, anyways, this is done. And what's remaining? E to the, this is there, sorry, 9 e to the power minus 20t plus 1, the whole power minus 2. Now let me take this down, okay? I will have above as 1800 e to the power minus 20t divided by 9 e to the power minus 20t plus 1, the whole square. Now we need to show that this is greater than 0. How do we do that? Before that, is our derivative same? Correct? Yeah, 1800 e to the power minus 20t, 9 e power minus 20t plus 1, the whole square. Why I double check it is sometimes I just do silly mistakes. You know, you just miss some things, like how I missed over here. So it might be silly, but don't do it in exam. You're going to lose marks. So be vigilant, be careful. Look at it more than once. Now let's see whether it's greater than 0. Greater than 0 means whatever value of t I put must be greater than 0. Now it's not possible to just keep on valuing. You can try this. Put a value of t, any value. Let me do it. Let me show it over here. Now in this equation here, I will write this equation as it is, 1800 into exponential e power minus 20 t is alpha x divided by 9 e to the power minus 20 t can be written as the variable alpha x plus 1 the whole square. Now let me take calc. Let me put the value of t as say 1. What is this? Is it a negative number? No, it's positive. Doesn't okay, well and good. It's greater than 0. Let me take another value. 2. Is it a positive? Yes, it's positive. This 10 to the power minus 15 means there is 14 zeros behind this 7. That's it. Let me take a small value, 0.5. I'm getting a proper answer. Okay, let me take a negative value. Now it should go wrong, is it? Now still it's fine. Let me take another negative value, 2.5. I am getting only positive answers. Let me take 0.9. It's fine. Let me take 0.25. I'm just getting values, proper values. What's happening? But can you do it for infinite values? No. But you're getting, see, by checking it, you're getting only positive values. Still now I've never got negative value. It's greater than 0. But actually you have an easy way to check it out. Now what is this? This denominator is squared. So doesn't matter what this value is. Here let it be a negative value or a positive value. Say negative 2 and positive 2. If you square these numbers, it's going to be only positive 4 both the ways. Negative numbers, when you square, it will become positive. So denominator can only be positive, nothing else. What about the numerator? This is positive 1800 and this is e to the power. Now e to the power, what is the graph of exponent? It goes like this. It just, see, it's like from here. It has asymptote at 0. It does not go negative. It does not go down. It starts at over here. It just keeps on going up, right? Now, doesn't matter what. You have a negative x value or a positive x value. Anything, the value, the range of e is only positive numbers. The range, the y value is always greater than 0 for e. So that means it can only be positive at the top as well. So therefore, it can only be positive numbers. So we can say this must be greater than 0. Why? Because it's only positive numbers possible. There is no negative numbers. I hope this is clear. This is how we can tell this c dash of t is greater than 0. Because both the sides, up and down, it's only positive. Why? Because down it's squared. It doesn't matter what number is inside, it will be squared and it will be positive. What happens in the numerator? Since we have a positive number multiplied with exponential, we know the range of exponential is only positive numbers. That means doesn't matter which t value you put over here, negative, positive, anything, decimal, fractions, anything, you will only get a positive answer. So it's all positive values. So that's why this is greater than 0. Okay, let's look at over here quickly. That's the reason. Okay, that's I think so explained over here. You can just write it, and also you can see that positive slope. It's a slope that's positive, so it just keeps on going up. It won't be negative. And now there's one more thing. They have told what? Determine that the concentration of the chemical never exceeds 10. Is it true? Now here, what you need to do is, this given the concentration, not the derivative of the concentration, you have proved this is greater than 0. How do you prove this to be positive? 10. Whatever is the concentration, take the limit towards infinity. Take this limit to infinity. Okay, that means change this value to a huge number and then see what is the answer. You can use a calculator for this. All you do is, now whatever is this value, I will just try to save time and I'll just edit it over here. I'll just remove all this. It's 10 divided by, okay, this is, I should have written it all at once. It would have saved me more time, I guess. But anyways, x plus 1 minus 1, no, it saved me time. Yes, absolutely. Now here, we have done this in the last chapter. You can use the formula, but it just takes time. All you do is type this as it is, press calc. What is infinity? Infinity is a big number, so let me try from 100. Or change this, 1000, 10,000. Always what's happening? After a certain value, see over here, after a certain value, it doesn't matter what, it's becoming 10. So if you go a huge number, Doesn't matter what, it'll just show 10. That means this does not exceed 10. From this graph, you can see over here, it just, plateaus or flattens out at 10. So let's see at 0.1, you can see there's some value. See at 0.1. Then even at 0.5, it's close. Sorry, it's closing in to, my tongue got stuck just now, and I made a funny sound, so it was very funny over here to me. Anyways, when you put any value, when say 0.5, it's closing to 10. As you increase the values, it'll just become 10. So that's how we can prove it. Or that's not the actual way, just still taking random values. It's this: take the limit towards infinity, and you can just prove it up. Okay, or over here, whenever it's a huge number to the power over here, what happens? This becomes 0 because it's negative, right? Where this cancels off. So you're remaining with 10 divided by 0 plus 1, and this is one way. Or you can just do it in calculator, and you can just prove it out. Just put a huge number, it's 10 directly. This you can write over here if you want to skip this. So that is how we solve this problem. I hope it is clear. And now we move on to another problem, that's log differentiation, and it's an easy one. Now before we come over here, I hope you remember the power rule. Power rule is x to the power anything, 3. It'll be 3x squared. Now here, there's an important thing to remember. You can't have this power anything other than a number, because in the power rule it states this number x to the power n is a integer, it's greater than 0, like that. They mention it, it's greater than 1, it's greater than so on. It can't be another function. But look over here, x to the power x. How would you solve this? Here, there is an important thing to remember. It's not a big, but anyways, how do you solve this is like this. Now, this is the function, right? Let me solve it from beginning. This is the function f of x. Here, f of x is equal to x to the power x. Now, there is no way you can solve this, not by power rule. Don't think it's x comes down and x to the power x minus 1. No, that's wrong. Now, how you solve this is taking natural logarithm on both the sides. Take ln f of x, that's the given function. That will be equal to, this comes down. Ln x power x. Now, when you take ln on both the sides, this power can come down. It will be ln f of x, that is equal to x ln x. Why? This is the property of log. This is the property of log. Now derive this. Derivation of both the sides. Now you need to derive, I'll write over here, derive or differentiate on both sides. Because both the sides there is no f dash yet. There's only function f of x, given function. So what you do over here, what you get is, when you derive natural logarithm here, it will become 1 by f of x. Why? Whatever ln x means 1 by x. Now we have f of x, it will be 1 by f of x. Then multiply it with what? Chain rule, whatever is inside you need to derive it. So f dash of x. Now we get the derivation. This is what we need to solve. They have told derive the function. So the answer, what we need to solve is f dash of x. Now we got it. This is it. Left side, it's only chain rule. Here it is a product rule, uv. We have done this before. It'll become u dash v plus uv dash. In fact, we had the same problem. Here what happens? U dash v, it's 1 multiplied by ln x plus x into 1 by x. Now I'll keep this left side as it is, f of x, f dash of x, that is equal to ln x plus 1. This x cancels. Now here we are almost done, but we need only f dash of x. So whatever f of x is there, bring it to the other side. So f dash of x is equal to ln x plus 1 multiply it with what? Multiply it with f of x. Now what is f of x? F of x is this. So you can write ln x plus 1 multiplied with x power x. This is the final answer. Or you can write x power x first. So you can see this. This is the final answer. ln x plus 1 into x power x. This is very, very important. Look, you take this function that is equal to x power x. Okay. Take natural logarithm on both the sides. You know, whenever there's equal to sign, when you do something to the left, you must do something to the right. The same thing. Sorry, not something. You can do anything you want. If I want, I can add 2 here, f of x plus 2. Even over here, it must be plus 2. It must be balanced all the time. So if I take natural logarithm here, I must do it in the left side as well. So I took ln on both the sides. Why did I take that? So you can solve this. This can come down now. That's the property of ln. Left side remains same. Now you derive both the sides. Derivation of both the sides will give you the chain rule at the left. It's ln dissolves and becomes 1 by f of x, derivation of f dash. Now if you're thinking how this happened, now imagine I had ln of x squared. The answer is 1 by x squared. That is like whatever is inside. Same 1 by f of x. See, whatever is inside. Multiplied with the derivation of this. Derivation is 2x. Now I don't know the function here. Like, I mean, I know the function, but I just write derivative of this, f dash. Okay. Or I can write here d by dx of x squared. That is the derivation. Okay. That is how we get that. F dash of x, that is equal to, over here you should use the product rule, 1 times ln x plus x into 1 by x. Now second term ln x will be 1 by x. Now simplify this, you get ln x plus 1, and now whatever is over here f of x, take it to the other side. From division it becomes multiplication. So when you multiply f of x, that's the answer. But what is f of x? We already know f of x is x power x, so you just write it over here. That's it. That would be the answer. I hope this is clear. And that's the end of this lesson. So we had 6 example problems. I hope all the problems are clear. If you have doubts, do post them in the comments. I'll try to get back to you as soon as possible. And some of you are asking me for the exercise problems. I will definitely do them once the exam scheme, the Heikel, is released. Then I will do the required example problems. Because of the time constraint, I'm just sticking to the example problems in the textbook, and these are relatable. If you understand these example problems, you can do the exercise by yourselves. And if some are tough, just do try to do it by yourselves, and then you can refer these videos. But once the exam scheme is released, I will do the exercise problems, whichever will be asked. And that's it for this video. A quick reminder, if you're not yet subscribed to my channel, please do subscribe. That would mean so much to me, and I really want to thank all those who have subscribed and those who all watch my videos. I greatly appreciate it. And until the next video, take care and bye-bye.